Welcome back, Pirates. It's Mr. Whaley here to walk you through one of the last lessons of this unit in trigonometry. Today we're going to talk about the law of sines. Now, when we talk about the law of sines, what we're talking about is trigonometry where you can find the missing sides and the missing angles of a triangle that's not a right triangle. I know often we think that trigonometry always deals with right triangles, but you can see in this picture, this triangle is clearly not a right triangle. Triangle A, BC is just some sort of triangle, and using the angles and the sides, we can find missing sides and missing angles. Okay, one key thing to remember, and this is important, and this comes from earlier in the year, is that if we have, let's say, angle A, across from angle A, we consider that to be side A. And across from angle B, we consider that to be side B, often notated with a lowercase letter. And across from side C, angle C is side C. Now that's going to become really important because over on the right, you see something called the law of sines. And it's a set of ratios that we can use to find missing angles and missing sides. And they use the sides in those ratios. Now, don't worry, you won't be using all three of the ratios when you go to solve a problem. You only use two of them. And when you have two of them, it'll set up a proportion that you can solve. Okay, well, enough of the abstract stuff. Let's look at an example. Ultimately, today our goal is to find missing sides and missing angles of triangles that are not right triangles. Okay, so let me clear off my screen. Let's take a look at our first example. Our first example shows triangle ABC. It's definitely not a right triangle. If there's a 95-degree angle in it already, it's impossible to have a 90-degree angle. Now, I know you might be thinking, well, that drawing's not accurate. That 95-degree angle looks like an acute angle. Okay, you're probably right, but that's not going to make a difference in what we're trying to do. All right, first thing I want you to do is make sure you label your sides. So if this is angle A here, side A is across from it. If this is angle C, side C is across from it. And if this is angle B, side B is across from it. Okay, let me get rid of my picture. I don't need to take up the whole screen on you. Okay. So in order for us to solve this thing, we're going to use the law of sines. And the law of sines says you take the sine of A, divide it by the side of A, and that should be equal to, well, in this case, we're not going to use sine B over B because we don't have information about B. We're going to do sine of C over C because those are the pieces that we have information about. Now we're going to substitute in and then solve that proportion. So the sine of 95 over A is equal to the sine of 30, we got a little bit of lag here, over 8. Now, we're going to go ahead and cross multiply this like you would any other type of proportion. But what I don't want you to do is I don't want you to round any of your decimals yet. So watch what I'm going to do. When I cross multiply here, I get sine of 30 times A is equal to the sine of 95 times 8. It looks like an 85, but that's a 95. Now, to get A by itself, we divide by the sine of 30. That'll cancel. That'll leave me with A. And over here, I would divide by the sine of 30 as well. Now, here's how we're going to type this into our calculator. Listen carefully. We're going to hit sine of 95, then close the parentheses and multiply that by 8. Hit enter, and you're going to get some long decimal. Don't leave that decimal there. Don't clear it out. Now divide by the sine of 30, close the parentheses, and you should end up with a number like 15.939115. This asks us to round to the nearest tenth, so I'm going to round that to 15.9. A is equal to 15.9. And that makes sense. Remember, we learned at the beginning of the year as well that the longest side is always across from the biggest angle, and the shortest side is always across from the shorter angle. So it makes sense that side A is longer than side C because angle A is bigger than angle C. All right, take a moment. I'm going to pause the video. You can copy down any notes you need to, and then we're going to look at one where we have to find the missing angle. Okay, I'm going to clear off my screen here, and moving into the one where we now have to find a missing angle. This is triangle DEF. So like we did in the last one, I'm going to label my sides. There's E, here's F, here's D. So it looks like we have E and F that we're going to be dealing with in this problem. So just like the last one, sine of E over the side of E is equal to the sine of F over the length of side F. Now, I don't use A, B, and C in this one because the triangle is not an A, B, and a C triangle. It's a DF. All right, so the sine of 99 over 110 is equal to the sine of F, which I don't know what angle F is, all over 85. Cross multiply like we did before, and I'm going to end up with the sine of F times 110 is equal to the sine of 99 times 85. All right. Well, let me not put that parenthesis in there. I don't want to confuse anybody. Okay. Now, divide by 110. Divide by 110 to start to get F by itself. But now we get to this point. The sine of F is equal to. Now, we're going to do this right in our calculator again. I'll guide you through it. Sine of 99, close the parentheses, multiply that by 85. You get a long decimal. Divide that by 110, and you should get something like 0.839535, something like that. Okay, I'm going to round it to there. Now, that's not what the sine of F is. That's not what F is. That's just what the sine of F is. So in order to find out what F is, we have to use the inverse of sine, that sine to the -1 button, and put in 0.8395 into our calculator. Make sure your calculator is in degree mode. If your calculator is not into degree mode, you're going to run into a problem with this. I think Mr. Albrecht walked you through that in a previous video. Okay, I get an answer of 57.0873735.846. Wants me to round this to the nearest tenth, so I will. I end up with 57.1 degrees as the measure of angle F. Okay, that one was a little bit tougher because we had to find the angle, so we had to use the sine to the -1 button. But all in all, we've practiced with that before, so it should be something we're comfortable with. All right, I'm going to pause the video. You can fill in any notes you need to. Okay, I'm going to delete this, clear this off. Now, for these last two, I'm just going to walk you through the setup because they each have something that's unique about them. Okay, and this next one, I think it's obvious what's missing here. We don't have a picture. It says, given triangle JKL, in which JK is this and KL is that, and the measure of angle J is 17, and wants to know the measure of angle L. I'm not doing this problem without a picture. So just draw any random triangle. Don't worry if it's not completely accurate when we're done. As long as you label it properly, it will work for you. JK is 14.3. KL is 5.8. The measure of angle J is 17 degrees. And it wants to know what's the measure of angle L. So it's clear that I have the sides and the angles I need to set up my law of sines. It would be the sine of 17 over the side that's across from it, 5.8, is equal to the sine of L, which we don't know, over 14.3. And now you'll go and you'll cross multiply and you'll do all that. Obviously, we should get an answer that's bigger than 17 degrees because that angle is across from the side that's bigger than 5.8. I'm not going to go through the whole thing, but what I want to get out of this is make sure you draw a picture. Okay, and then in our last one, this last one is unique, and it says in triangle BOY, B is 100 centimeters. Okay, so B is across from angle B, so I'm going to write that in. That's 100. Measure of angle B is 70, and the measure of angle O is 50. And it wants us to find side Y, which is over here. Now, if you're like me, you're thinking, well, I could probably find side O pretty easy because I have the angle for that. But I don't have any information about y, so you might be thinking it's impossible. But don't forget about our old friend, the triangle sum theorem. If angle B is 70 and angle B is 50, together they make 120. So that makes angle y here 60 degrees. And now I can use the law of sines to solve for side y. Sine of 60 over y is equal to the sine of 70 over 100. So sometimes you may need to do that extra step. All right. Well, good luck. Give a shot with the homework. If you have any questions after you've done the homework, we usually post the answer key. Feel free to reach out. Good luck, Pirates.